In this video we're going to look at how to find the mean and the median from a group frequency table. So in this case we have 4 groups of data, and we can see that there's data for each of these 4 groups. And we're going to calculate the mean and the median, and in order to do this I'm going to need to use a few extra values, so I'm going to extend this table from how it is initially. And in order to calculate the median, it's going to be useful to have a cumulative frequency column. So I'll add that in. And in order to find the mean, it's going to be useful to have a midpoint column. And then a midpoint times frequency column, which I'm just going to write as n times f for now, just because I'm running out of room. Okay, so the cumulative frequency column, I'm just going to add up the values as I go down. So 7, and then the next one is adding the 5, which is 12, then adding the 4, which is 16, and finally adding the 6, which is 22. The midpoint is going to be the midpoint of this group. So this group actually goes from 11.5 to 14.5. And the reason for that is because of the way that this grouped data has been represented. Well, between 14 and 15 I've got a gap, so the true boundary is halfway between that, so it's 14.5, and we've got a similar situation at the beginning of this group. So this is actually looking at the midpoint of 11.5 and 14.5, which is 13. And if I go through this same procedure, I get these following midpoints. So the midpoint times the frequency is then multiplying these two columns together. So 7 times 13, which is 91, 5 times 16, which is 80, 4 times 19, which is 76, and 6 times 22, which is 132. So we're going to actually look at the mean first, because that's slightly easier. So we're going to use the same formula, which is sigma fx over sigma f, which is what we used when we had discrete data in a table. So sigma fx is the sum of my midpoint times frequency column over the sum of my frequency column, which I can actually just use this last value of my cumulative frequency. So there's 22 bits of data, so I can now calculate that. And that gives me 17 and 5 over 22. As a mean, that looks sensible, always worth having a quick check. So now I've got the median. So in order to find the median, I'm going to divide my total bits of data by 2. So 22 divided by 2, which is 11. And that means that the median is the 11.5 value, or 11.5 value, because it's in between the 11th and the 12th piece of data. Now in general, when you're finding the mean, you divide the total number of bits of data by 2. If you get a decimal answer, you round up to the nearest whole number. If you get a whole number, you go up half a unit, so to 11.5. Now I can see from my cumulative frequency column that the first 7 bits of data are in the 12 to 14 range, and the next, well, all the way up until the 12th bit of data are in the next group up, so my median is somewhere in that group. And I'm going to use a method known as interpolation to estimate how far through that group it is. And I find it useful just to kind of use a diagrammatic way of looking at it. So on this, above this line, I'm going to show the values of the group. So the lowest value of the group is 14.5. The highest value of the group is 17.5. And my median, which I'm just going to call M for now, is somewhere in that group. Now if I look at the frequencies, well, at the beginning of the group there are 7 bits of data because they're from the first category. By the end of the group there's now 12 bits of data, and my median is the 11.5th piece of data. And these are going to be in the same proportions because we're going to assume that the proportion of the way through the 11.5th term is through the cumulative frequency is the same proportion that the median is in this group. So I can then set up a little equation. So m minus 14.5, which is that distance there, if we think of it as a distance, over that total distance, so 17.5 minus 14.5, that is equivalent to the same on the other side of the line, so 11.5 minus 7 over 12 minus 7. And now I've just got this equation I can solve. So I could simplify it, or I could put it in just one go. So I'm actually going to simplify it. So 17.5 minus 14.5 is 3, 11.5 minus 7 is 4.5, 12 minus 7 is 5. So from there I can then work out that my median is going to be 14.5 added to 3 multiplied by 4.5 over 5. That's just by multiplying through by 3 and then adding 14.5. So this I can now evaluate. And I get my answer of 17 and a fifth. Now, does this seem reasonable? Well, 11.5 was very nearly the end of the group we were looking at, and 17 and a fifth is very nearly at the end of this. It's actually past the data that's shown here, but it's not as far as the 17.5, so that's still within this group.